Hi, this is John, and here is episode 2 of the Squares space game tutorial. So far, from episode 1, what we have is a rotating spacecraft that rotates left and right using the arrow keys, thrusts with a thrust graphic using the spacebar, and fires bullets in the direction of motion. We also have a wraparound that wraps from the top to the bottom of the screen, from the bottom to the top, from the left to the right, and from the right to the left. The next thing we're going to do is create some opponents. Our opponents are going to be squares. That's the name of our game, Squares. Rather than position our squares on the screen at the beginning of the game, I'm actually going to use a game functions actor to spawn the squares at the beginning of the game, and we'll see why in a moment. In order for the game functions actor to be effective, the game functions actor must be in the scene, but off of the screen. So he's not visible, but he's present. And you recall we did this in previous examples with the score counter, which was controlled by a game functions actor that was in the scene but not visible on the screen. So what the game functions actor is going to do is spawn actors. And the actor we're going to spawn is the square. And the square can be spawned at a position. We're going to make that position relative to the scene. We don't want to make the spawn location relative to the actor because we position the actor off of the screen. We want it to be relative to the scene. So if we want it to be in the lower left-hand corner of the screen, we could put in something like position 100, 100, and when we preview, we can see that our square opponent has spawned 100 pixels on the x-axis, 100 pixels from the left edge, and 100 pixels from the bottom of the screen, 100 pixels on the y-axis. I'm going to make our square a little larger, about 60 pixels by 60 pixels. Now, one of the interesting things I can do is by spawning my actor using the game functions actor, I can select a random position for that actor to take when spawned. Using the equation editor, I can add a random function. And this is going to generate a random value between a minimum and a maximum. Since this is my x position on the screen, my horizontal position, I want my value to be between 0 and the right edge of the screen, which we know to be the game display size width. So just to review, I'm positioning my spawn square horizontally at a randomly generated value between 0 and the width of the screen. Let's take a look at what this does. Every time I refresh the game, my opponent appears at a different randomly chosen location. I can do this again for the y value by inserting a random function between a certain minimum value, which will be 0 at the bottom of the screen, and a maximum value, which will be the game display size height. So now my actor will appear at a random x and random y coordinate on the screen. I can also have my actor moving in a random direction. Of course, my actor is not moving, so let's go back into our square and give our square an accelerate behavior. And we'll have that direction within the actor be 0. But when spawned by game functions, it will have a random direction. Go into the equation editor, again choose the random function, and in this case we're dealing with random degrees from 0 to 359. So we're choosing a random direction within the circle. So now my actor is spawned at a random location with a random direction. Additionally, we want our square to have the same wraparound behavior as our rocket. So we can go into our rocket, copy the edge rules from the rocket, and use Command C to copy, and paste those edge rules into our square using Command V. So all of our edge rules come into the square, and because we set them up with self position X, that self applies to the square the same way self applied to the rocket when the rules were within the rocket. So our square should obey the edge rules. The nice thing about this is that since we've done this once within our game functions actor, by option clicking and dragging, we can spawn multiples, and each one of them has the random functions within it. So each one of these actors, when spawned, will start at a random location and a random rotation. We can also create randomness within our actor. For instance, if we want our squares to rotate through space, we can give them a rotate behavior and have that rotation occur at a random speed from, say, 1 to 10. And now my 3 squares appear at random locations, and each of them has random rotations. Now notice that they're moving in circular paths. Now that they're rotating, their acceleration is changing relative to their angle. So we want to switch accelerate relative to scene, so that the rotation doesn't affect the direction in which they're moving. A few more things to add here, but they're slightly more complicated. Now that we're accelerating relative to scene, our squares are all moving in the same direction. They're also all accelerating at the same rate. But because accelerate is a continuous function that's recalculated every frame, we can't simply add a random function here, because the random value will be recalculated every frame, and we won't achieve the desired effect. Instead, what we have to do is a little bit more complicated. What we have to do is to create 2 new attributes for the square. We can add those to the attributes section. They will be integer attributes. One will be direction, and one will be acceleration. Again, the reason why we need to create these attributes, rather than just putting the random function inside the behavior, is that whereas the speed of rotation is calculated once at the beginning of rotation, the direction and acceleration of the accelerate behavior are recalculated every frame. So what we want to do is establish the direction and acceleration when the square is first created, and then continue to accelerate at the rate of acceleration in the direction that's chosen at the beginning. So we'll use the change attribute behavior to change the square's initial direction and the square's initial acceleration. And here is where we can insert the random function. For direction, it'll be between 0 and 359 degrees. And for acceleration, it can be whatever we want. We'll say from acceleration between 1 and 12. And then, importantly, in the accelerate, we want to accelerate in the randomly selected direction, and we want to accelerate at the randomly selected acceleration value. It might be clearer to put this accelerate below the change attribute rules, so that we're seeing that we're randomizing the direction, randomizing the acceleration, and then accelerating in that direction at that acceleration. So our squares are rotating. At randomly chosen rates. Each has its own randomly chosen acceleration, and each has its own randomly chosen direction of acceleration.